Alright, what we started today in our introduction to trigonometry had to deal with, trig being the idea of measuring triangles and measuring angles. And one of the main things we talked about is if we have an angle, we always start with an initial side, and then it's like we've taken this and rotated it up to make a terminal side, and this is the angle that we'll end up talking about in the middle. Now, when we do trig, a lot of times we're going to talk about being on a coordinate plane. Just for some reminders, we talked about our quadrants, quadrant 1, 2, 3, and 4, going in that clockwise manner. And what we do here is that this is our initial side, and then we would say, well, this would be our terminal side. So here's the angle that we're looking at. And the main thing to look for is the fact that in quadrant 1, you're going from somewhere in 0 degrees to this would be a 90-degree angle. So quadrant 1 has to be somewhere in that range. If an angle is here in quadrant 2, it would have to be between 90 and 180 degrees. Quadrant 3, 180 and 270 degrees. And then quadrant 4 be between 270 and a full circle, which is 360 degrees. Now, degrees are great. We've done them for years. However, we don't like degrees when it comes to upper level math. So what we're going to use is something called a radian instead. And a radian simply is a measure that makes an arc equal to the length of the radius. So here's a initial side, and let's say we rotated it and we make an angle that goes, let's say, to this spot right here. Okay? This arc that it creates is the same length at this spot as the radius. That means this angle is actually 1 radian. This angle right here is 1 radian. If I do it again, it ends up about right there. That makes 2 radians. If I do it a third time, it gets to be about right there. That's 3 radians. 4 radians takes me down to about right there. 5 radians takes me down to about right there. And 6 radians to about right there. So, to go around a full circle, the whole way around, which would be a circumference, it's a little over 6 radians. Well, something to think about. However many radians, whatever your arc length is how many times the radius we have. So here's 1 radius, 2 radius, 3 radii, 4 radii, all the way around. Well, if we want a full circumference, how many times the radius do I have? Well, the answer actually is right there in our circumference formula, which is 2 pi. So really, if I want to talk about radians, it's a little more than 6, but it's actually exactly 2 pi. And we're going to think of pi just in that terms. We don't want to actually multiply out 3.14. Another way to look at it, so that's 2 pi radians. If that's a full trip around the circle, what's only half of that trip? 180 degrees is just 1 pi, half of it, half of a 2 pi radians. What if I only wanted to go half of that, to 90 degrees? That would actually just be half of a pi, or we call that pi over 2 radians. And, well, if I didn't go anywhere at all, that means my arc length doesn't exist. That means it has to be 0 radians. And the only one left down here, halfway between pi and 2 pi, will be a pi and a half. Well, we don't like mixed numbers, so I'm going to make it improper 3 pi over 2 radians. Okay? That's the basics of the radian measurement. Now, the other thing we want to look at is the idea of coterminal angles. And it just means literally what it says. They end at the same spot. So I have this angle right here, which is 45 degrees. Well, let's first look, what would that be in radians? Well, we said this here 90 degrees was pi over 2. Cutting that in half means it would be pi over 4. Now, what if I got to that same ending point in a different manner? What if I accidentally passed it, came all the way back around, and hit it again? Well, that would be going a full trip around the circle, which is 360, plus another 45 degrees. So that would give me 405 total. That was 360 plus 45. In radians, I do the same thing. Add them up. I have a 2 pi for the 360, for 360 degrees and the 45 degrees. The 45 was pi over 4. When I add those up, I would end up getting common denominator 9 pi over 4 radians. That's a coterminal angle. These two angles really mean the exact same thing. Now, who's to say I have to go that way? What if I go in the opposite direction? Well, just like on a number line, if I went the opposite direction, I would have a negative number. Same here with negative degrees. Well, this is negative 90 180, 270, plus another 45 means I get a negative 315 degrees for that guy. Now to turn that into radians, same thing. Well, let's think about it. If I went all the way around, it'd be a negative 360 degrees, a negative 2 pi. But I want to take away a pi over 4 from that. So really that's saying, I want to say 360, but I want to get rid of, so we really add back that 45 degrees. That'd be the same as saying I have a negative 2 pi, but I need to add back that pi over 4. I end up getting 7 pi over 4 as my answer. I'm more worried right now about, do you understand that coterminal means I can go either direction, positive or negative direction, and I can go as many times as I want. This would be the same coterminal angle. No matter how many times I go around, as long as I end at that exact same spot, that'd be a huge angle, but it's still the exact same. Well, there you have it. That's everything you need to know on the intro to radians.